All right, number 61. We are trying to find the radius of convergence, just like number 60. So we will apply the ratio test. So we have k. You can obviously change this to n. You don't have to use letter k. So we have the limit as k goes to infinity of x minus 2 to the k plus 1 over, then when you replace k with k plus 1, that will actually give you 5k plus 5. And then you multiply it by the reciprocal, so you'll have 5k factorial and over x minus 2 to the k, which is the original function. So what happens is these x minus 2's will just leave an x minus 2 on top, and then technically the 5k plus 5 factorial would go 5k plus 5, 5k plus 4, blah, 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 blah. And what I'm showing you here, I didn't show the 5k factorial, but 5k factorial would have canceled with the 1 on top. So, anyway, you're left with a bunch of k's on bottom. You're left with an x on top, but since this is the limit as k, or normally we use n, goes to infinity, you're clearly going to 0 here with those k's left on bottom. So when that goes to 0, that means you have convergence for all values of x. So when that's the case, you have the radius of convergence is infinity, because the interval of convergence would be from negative infinity to infinity. Now here's number 62. We're just trying to find the Cartesian equation, which is just the standard xy for a parametric. So this is pretty easy, just a little algebra here. So you see these are in parametric form. You have x equals the square root of t. You have y equals 4t plus 8. Technically, there's two ways you could do this, but only one way that will match this answer. So if I let x equals the square root of t, you square both sides, that means t equals x squared. So then I substitute x squared into the t right here on the y equation. Will give me y equals 4x squared plus 8. I guess what I meant by the other way that you could technically mathematically do this is if you solve for the t on the equation for y, and you'd have y minus 8 over 4, that equals t, and then you would substitute that into this other equation, so x would just equal then the square root of that. That would also be correct. But the answers here are telling me they wanted y in terms of x. But I just did want to mention that there was another way to do it. All right. Number 63. Same kind of problem. So x is already written as t minus 3, so you just solve for t in terms of x, so that's easy. Makes that t equals x plus 3. So you have y, and then you substitute that into the other equation, so you have y equals x plus 3 squared plus 5. So you square that out. X plus 3 squared is x squared plus 6x plus 9. Add 5. So the Cartesian equation then would be y equals x squared plus 6x plus 14. Number 64. We're going to find the equation of the tangent line to the curve at a point given by at a value t. Well, we're just using parametric equations, but the idea, of finding the equation of a tangent line is something we've encountered before. So mainly you need the slope, which is the derivative, and then you need a point, and then with that, that's all the information you need to come up with the equation. So I'm going to use the formula for the derivative in parametric form. In other words, I didn't write the formula here, but I'll just show you. I'm using it though. In other words, dy dt is defined. Dy dx is defined as dy dt divided by dx dt. So dy dt, the derivative of 12 cotangent of t, Well, it's very important that we know the derivative of cotangent t is negative cosecant squared. So it'll be negative 12 cosecant squared t. And the derivative dx dt of cosecant will be negative cosecant cotangent. So I'll put that on the bottom, the denominator, so the negatives cancel. One of the cosecants cancels. So you're actually left with cosecant over cotangent. I simplified it. We didn't have to simplify it, but what happens is that cosine is 1 over sine, cotangent's cosine over sine. So if you wrote that out formally, you would say the signs cancel, and you're left with a cosine on the bottom. But you could have absolutely just put the value for t of pi over 3 right here into this equation. It was not necessary to go from this to this. I just only wanted to plug in the value once. So that was not required. So now I'm going to find the slope here, which at pi over 3. So cosine of pi over 3 happens to equal 1/2. So you have 12 divided by 1/2, which equals 24. So we know we're working with y equals 24x plus b. All right, so now we need x and we need y. So x is cosecant of t. So right there, I'll replace the x will be cosecant of pi over 3. And then y is 12 cotangent of t. So where I have y now, on the left side, I have 12 cotangent of pi over 3. So I simplify this using the values. Cotangent of pi over 3 will be 1 divided by square root of 3. It's cosine of pi over 3 divided by sine of pi over 3. You can look at a unit circle and put that together pretty easily. Cosecant of pi over 3 is 2 over the square root of 3, because it's a reciprocal of the square root of 3 over 2. So let's see, because we're trying to solve the value for b here. So I've got 12 over root 3 equals 48 over root 3 plus b. So if you subtract the 48 root 3, move it from the right to the left, you have negative 36 root 3, which normally that's fine, that's correct. But to match these answers, I did need to rationalize that denominator, meaning multiplying top and bottom by square root of 3 over square root of 3, which will give you a 3 on bottom. 3 goes into 36 12 times and leaves that root 3 on top. So b is negative 12 root 3. And we already know that's going to be y equals 24x, so we just found b. So our equation is going to be y equals 24x minus 12 root 3, which is answer A. Very good. So number 65 says find dy dx without eliminating the parameter. Because technically, sometimes you could do this. Sometimes it would be too difficult to do this, so you wouldn't want to. But let me go back to one of these other examples. Well, not other problems we just did. Like this. If you wanted to find dy dx, so we could actually, you could do it dy dt over dx dt and get it in terms of t, but then, you can also take the derivative of y in terms of x. But if the answer is supposed to be in terms of t, you would have to substitute back in there to make it in terms of t. So they're saying without eliminating the parameter, they're saying, in other words, use the t's, don't solve for t in terms of x. So the x is 1 minus 2 cos t, so the derivative, because of that negative in front, will make it positive 2 sine t. dy dt, the derivative of 1 plus 6 sine t will be 6 cosine t. So we put dy dt's in the numerator, so it's 6 cos t divided by 2 sine t. That simplifies to 3 cotangent t, which is answer D. Excellent. Number 66. Length of the curve. So we have a formula. It's on your formula sheet for arc length. It's the square root of dy dt squared, dx dt squared plus dy dt squared. Put the formula there, but it's on your formula sheet. So if x equals 3t, dx dt would be 3. And dy dt, the derivative of 2/3 t to the 3/2, would just be t to the 1/2. 3/2 would cancel the 2/3. And we're from 0 to 16, so we know we're integrating from 0 to 16. Now these problems are designed, and they certainly would be on my test, to, the radicals can obviously cause issues when you're integrating, namely trig substitution, stuff like that. But these are designed to work themselves out to where they're generally going to be U substitution of some sort. So they're not designed to have to go into that much difficulty. So 3 squared is 9. T to the 1/2 squared is just t. So you have the antiderivative of square root of 9 plus t from 0 to 16. Now at this point, if you're using a calculator that does numerical integration like this one's kind of old school here. We have to type in the command like that. The newer operating systems for these, like TI-84, things like that, it will show the integration symbol. I'll open that up here and come back to that. Anyway, and it'll give you the answer. Now, sometimes they may not convert to fraction, but that's okay because all you have to do is you can check your answer choices to see if they have the equivalent value, whether it's not exact or not, you would know which one's correct. Okay, let's go ahead and do this while we're here. So we have math and number 9, the F in it. So there we go. So it shows it like you would normally put it into an integral. But now if you're using a little bit older one like a TI-83 or something, you can see how I did it the other way. So that will give you, I'm just going to use x here. I don't have to use variable t. Because when you're just integrating, it's just going to integrate it as whatever, as long as you put x everywhere. There it is, same answer. But anyway, let me just kind of walk through this real quick on the substitution, because I'm certainly not trying to dismiss integration skills, which are important, especially if you have tests where you have to work out, show your work and that sort of thing. I was just specifying for the purposes of a multiple choice question, you would not need to, but people may need to for a handwritten. So I'll let u equal 9 plus t, so du is dt. I'm a big fan of changing my limits of integration. Makes it easier, I think. So if I put 16 in there, I get 25, 9 plus 16. I put in 0, I get 9 plus 0 is 9. So the reason why I do this, I change it because that way I never have to go back to variable t again. I can plug the numbers into, after I integrate, I can plug them in for u, and that's it. I don't have to worry about changing u back to t. That's the best feature of it. So the antiderivative of u to the 1/2 du will be 2/3 u to the 3/2. Put in 25, put in 9. And sometimes with these problems, you'll have, these just happen to work out to where they're, those numbers are integer values. Sometimes you'll just have something like, 37 to the 3/2. That just means it's 37 to the 3/2, or it could be written as 37 square root of 37. These work out nice because to the 3/2 power, that means you're taking the square root of 25, which is an integer, and the square root of 9, which is an integer. So that works out. So, and then it ends up being exactly 196 over 3, like it's supposed to equal. So answer B was correct. 67. Cartesian coordinates corresponding to polar coordinates. Formulas on the formula sheet, they're not written here, but I'll just say them verbally. X equals r cos theta, y equals r sine theta. So they're in polar form. The r would be square root of 3. theta would be pi over 6. And so cosine of pi over 6 is square root of 3 over 2. So square root of 3 times square root of 3 over 2 is 3 over 2. And then sine of pi over 6 is 1/2. So you multiply those together, you get square root of 3 over 2. And it will be answer D. The Cartesian coordinate would be 3/2, comma, square root of 3 over 2. So number 68, we are taking Cartesian coordinates. We want to find the polar coordinates, which, there's actually two ways you can do these. Sometimes it may ask for r being negative or r being positive, most likely positive, but so here they're making it clear that, well, at least non-negative. They're allowing 0. They're saying theta's got to be between, it's kind of tricky, isn't it? Look at that. All right, I should have checked the spacing on that. But I was wondering, that was strange between 0 and 2, but there's the pi over on the next page, so it's between 0 and 2 pi, which that makes sense. So we don't have to use every possible coterminal equivalent. All right, once again, from your formula sheet, you would have that x squared plus y squared equals r squared, which means r equals the square root of x squared plus y squared. So negative 7 squared plus 7 squared, that's actually the square root of 98, which the square root of 98 simplifies to 7 times the square root of 2. And then now for the theta equals tan inverse of y over x. Now, if you do this in a calculator, of course, if you do it in degree mode and then convert it to radians, I think that would be the way to do it, because the decimal radians aren't so obvious. So if you went, let me check my mode here. It's in degree mode. So if I go second, tan inverse of negative 7 divided by 7, or if you can just see that that's negative 1. You see that's negative 45, but the instructions said our answer has to be between 0 and 2 pi, which is no trouble. Just, I can convert it to radians right now if I want to, or I can just add 360 degrees, then convert it back to radians. So it's 315 degrees, which then also translates on the unit circle to 7 pi over 4. So in other words, the negative pi over 4 is not mathematically wrong. It's just not the equivalent coterminal value that fits from 0 to 2 pi. So that's often the case when you're having to convert from Cartesian to polar, that you have to pay attention to the specifics of where the angle should lie. Alrighty, number 69. Convert polar to rectangular. Now, there's different ways these can be expressed, and of course, in multiple choice, you're picking the right answer. But if you were writing this out, there's different ways this could come up. Like obviously you could have y squared minus 4x equals 0 or something like that. But anyway, the main thing is you're getting rid of all r's and thetas, and you're getting everything into y's and x's. All right, because I know that x equals r cos theta and y equals r sine theta, so I'm going to work with that. Now, so I want to take this cotangent and cosecant and immediately convert it into sines and cosines. So cotangent is going to be cosine over sine, and cosecant is going to be 1 over sine. Like I said, you might do this a little differently than not exactly, but this is correct what I'm doing, but there might be slightly different ways to do it. So what I did is basically brought these two sines over as sine squared and brought them up, and on the left side I have r sine squared equals 4 cos theta. Now, over here, I can pair up r with one of the sine thetas to give me y. The problem is I would still have a leftover sine theta. See, the sine and cosine of theta have to have an r to convert over to x. So that's why I'm multiplying both sides by r. It takes care of my goal on both sides. So then multiplying by r on the left side gives you r squared. So now I have two r's and two sines. So basically it's r sine theta multiplied by itself. So it's y times y, r sine theta gives you y squared. And then on the right side you have 4 r cos theta, and r cos theta is just x. So oftentimes I'll see students make the mistake of, just changing cosine theta over to x, or same thing with sine theta over to y. But you got to have that r with it. So in this case, it takes r cos theta. It takes all of that to make that x right there. And there you go. So the equivalent rectangular equation would be y squared equals 4x. Now we're going the other way. Now, one thing it doesn't say here, but we're eliminating, I think it would be obvious also that we don't want r equals 0. That doesn't really accomplish much, so we would lose that solution. So here's what I'm going to do. I'm going to use the conversion. I'm going to say x squared plus y squared equals r squared. 4x would be 4r cos theta, so that equals 0. So I factor out an r between those two. And so we don't, in other words, we don't, that's why when you factor this out, you might have first looked at this and go, hey there, fella, did you forget something? Well, I'm going to say it right now. That would be but we don't need that as an answer. It's not as important as in other mathematical situations where we would want that 0. We do not want it here. So we're only dealing with the other part. So if you have r minus 4 cos theta equals 0, that means r equals 4 cos theta. There we go. Now, number 71 and 72 are involved finding the area inside one leaf of a 4-leaf rose. Now, the number of leaves would only be necessary really because we don't need to know how many leaves there are to find the area of one leaf. That's not important. But we would have needed to know the number of leaves if we were trying to find the total area of the leaves. We didn't know how many. Because in this case, 4-leaf, you'd find the area of one leaf, and everything's symmetrical. So you would, and then you just multiply that answer by 4. I'm going to see if I have better luck with this one. Now my window's probably not what I want it to be here. Let's go zoom standard for now. Oh, okay, that one worked. All right, there's our 4-leaf. Lucky 4-leaf rose there, clover. Alrighty, now there's a big difference. I have an example here. Oh, there it is too. Okay. Guess I should look at my own work, shouldn't I? A little bit different how you handle this with sine or cosine. So I probably have on the instructions for the problem list for the final one of these two. So that's why as long as we cover both of these. Probably doesn't tell you whether it's sine or cosine. So long as you know how to do both, you're good. Okay, doke. They're going to be different because whenever you're dealing with sine and you put 0 in for theta, that means your graph will start at the origin because sine of 0 is 0, 7 times 0 is 0, so r will be 0. Now what we have to do is we have to figure out what's the value for theta where it completes that loop. And to do that, just like in my notes, you need to know when is the first value for sine where it's going to be 0 again. And if sine of 0 is 0, the next value in the unit circle is going to be pi. So all you have to do, so it'll be pi every time, so you'll do the same process every time, because this is very important that, how we get our upper limit of integration. So all you do is this, you basically just set pi equal to 2 theta. So 2 theta equals pi, therefore theta equals pi over 2. All right, so that's what we have right there. That means when theta is pi over 2, it will complete its full leaf pattern there. So that's the key part of this problem, is getting this right. So the setup's going to be, I didn't have the formula here, but it's on your formula sheet. It's 1/2 times r squared d theta, where r is a function of theta. So r is a function of theta, so it's r squared d theta, and then the limit 0, so it's very important that we got that pi over 2. All right, so you can, use integration technologies, being on a multiple choice question. If work is not required, you can do it that way if you want, but I'm going to show the work here, because you only have to really get the decimal equivalent to this. Alrighty, so you square that out, you're going to get 49 sine squared 2 theta, so I'll bring the 49 out with the 1/2 to make it 49 over 2. We use the integrating identity for sine squared, which is 1 minus the double cosine of the double of that angle. So 2 theta becomes 4 theta, all divided by 2. And so we have 49 over 2, and we have 1 minus 4 cos theta over 2, so you can bring that bottom 2 out with that 2 to make it 4. 49 over 4. The antiderivative of 1 will be theta. Antiderivative of cos of 4 theta minus cos of 4 theta will be minus 1/4 sine of 4 theta. So you plug in pi over 2. So we plug in pi over 2 for theta. That'll give you pi over 2. Put in pi over 2 sine of 4 times theta. 4 times pi over 2 will be 2 pi. Sine of 2 pi is 0, so the 1/4 doesn't matter. And for this one, it's going to be 0 in both ends, because sine of 0 will be 0. And you end up with 49 over 4 on the outside times pi over 2. So the exact answer is 49 pi over 8. So in the calculator, you don't have to even use theta. You can just go to the f and n and just use x as your variable. I forgot to put the 1/2 in front there, so, which I could have taken care of that at the end, but 1/2 times math 0, and we're going up to pi over 2. Seven times sine. I guess actually I am in polar modes. I guess it'll, okay, well that'll be all right then. I didn't change out of it, so that's fine. So what I need to do is I need a parentheses here. Theta here. I gotta get a square in there somehow. Now I gotta get rid of this. And since they changed the way to enter stuff, it's making it more confusing. Usually I could arrow right past this and put my square right after that parentheses, but it won't let me. Maybe I'll try it this way. It kind of made it more complicated. No, that's wrong. Parentheses squared. I don't like the way that's written mathematically, but it might be right. I like to put the square above the trig function. But this might be accurate. We'll see. Well, okay, so there's, and that's certainly not right then. Okay, so it probably needed, I think I would have to get a set of parentheses around the sign. Yeah, I could do this better with the other operating system, but this one's maybe, no, I gotta get the parentheses there, and then delete this one. But that doesn't match 49 pi over 8, which I promise you is correct. So, well, all right. So, lesson learned, proceed with caution if you're going to do these in the calculator. So, let's do the next one. 3 leaf rows. R equals 4 cos theta, for 4 cos 3 theta, excuse me. Now, here's where cosine is different than sine. Now, here's the way I like to do this. You can choose to do it differently, and I'll tell you the alternative method. I don't think I showed this here. Now, I did in my notes, my lecture notes, show the alternative way to do this, but I didn't show it here. I like to start with 0 as my lower limit, but for cosine, see, cosine of 0 is 1, so actually for cosine, instead of the graph starting at the origin and making a loop all the way around, it will start out here somewhere, basically whatever that number is on the outside, 4. So it's starting here, and then I'm going to figure out then when does it cross the origin right there. And that will complete half of the loop for me. And that's okay, because half of a loop there, half of an area, just all you have to do is multiply that by 2, and that will give you the area of the entire leaf. I'll just tell you real quick, the alternative way would be to figure out where it hits the origin, and then figure out where it hits the origin again, and use those as your limits of integration. And you wouldn't have to multiply it by 2. So if you want to do that, that's fine. But I like using the 0, so I usually go with it this way. And so sort of do like I did the last problem, except we're not setting this equal to pi. See, last time I said it equal to pi because sine of pi is 0. Starting at angle 0, where cosine equals 1, the first time that you get to 0 for cosine will be at pi over 2. So this time I want to set 3 theta equals pi over 2. Therefore, divide by 3, that means theta will be pi over 6. Because that way you'll have cosine times 3 pi over 6. And that'll be 0. So if I have the 1/2 out here, so I have 1/2. Now in my notes, I went ahead and put a 2 out there at the beginning, which certainly is correct. Put a 2 and then you cancel the 1/2 if you want to. It looks like I waited until the end and did it. So I don't know. You can choose whatever's best for you. So it's 1/2 times 4 cos 3 theta squared, which will give me 16 cos squared. So the 16 with the 1/2 multiplied make 8. So it's 8 cosine squared. So I will use that integrating identity for cosine squared of 3 theta, which will be 1 plus cosine of 6 theta over 2. So you bring the 2 out with the 8 to make that a 4. And then the antiderivative of 1 will be theta. And the antiderivative of cosine of 6 theta will be 1/6 sine of 6 theta. Now we plug in our limits of integration. Pi over 6 will get you pi over 6. 6 times pi over 6 will be pi. Sine of pi is 0. So that just turns into 0 right here. And then when you put in 0, they're going to be 0 at the lower ends. So you just end up with 4 times pi over 6, which is 2 pi over 3. So if you don't put the 2 in the beginning like I did in my notes, you will have to multiply it by 2 right here. So 2 pi over 3 is not the correct answer. You have to multiply it by 2 to get 4 pi over 3. And then for some reason I threw in for this one what it, asking for all the 3-leaf rows, whatever. So the total area of that entire, all shaded regions would have been 3 times 4 pi over 3, which is 4 pi. I just put that in there just to show you. Mainly it's finding inside one petal. And so the key answer here is the 4 pi over 3. Oh, excuse me. I'm sorry. I apologize here. No, it did ask inside the 3-leaf row, so I did do it for a reason. It was for all the petals. That's why you had to know it was 3 leaves. So, excuse me. So we had to get 2 to get to 1 petal. So if it had been 1 petal, 4 pi over 3 would have been the answer. Answer C, for only 1 leaf inside the 3-leaf rows, means inside the entire thing. So it would have been times 3. So excuse me then. So 4 pi is the correct answer, because it's including all the shaded regions. And that concludes this video.